Welcome back, my friends, to another IM3 video. Let's go over some math. We're in Trig in chapter 9, and in this particular problem, we're given the cosine of some angle equals a fraction. And what's particular about this is that this is not one of the fractions, one of the values that we have on the unit circle, the ones that have the specified amounts, the multiples of 30 degrees and 45 degrees. And so we're going to have to do some math to try to figure this out. And what I recommend you do, if you really want to take this apart, is that you start by sketching a unit circle, just so you have kind of an idea of what you're looking at. Nope. Close enough. And let's label this a little bit. So we have cosine is negative 5 over 13. I'm just going to estimate where this is. This is quadrant 3, so that's here on the bottom left corner. And so that's it's actually less than half. So it's probably, let's just roughly eyeball it about right here. That's probably not exactly right, but that's okay. And we're going to draw a line from the center of the circle. And I'm just going to remind you what this means. So what this means is that there's some coordinate here, and the cosine is negative 5 over 13. And then the sine is some value that we don't know. And we have to find both sine and tangent, and we're not even given an angle. How is this possible? Well, it's possible through the power of Pythagoras. So let me label some other sides here. I almost wanted to change the color. You know what? Let's not do it down there. Let's do it up here like normal. The sine, if you drop a height down to the x-axis, the length of that purple segment there is going to tell you the sine. And the length of the green segment, which is right here, that's going to be the cosine. In fact, maybe I should improve the color coordination. And so the green value here is negative 5 over 13. So basically, we need to know the purple value. Well, we know the blue value is 1 because it's a unit circle. And so the green value here is 5 over 13, negative that is. And so now all we need is that x value there. Right? We should really call it y. In fact, you know what? I will call it y, because it is the y value here. And because this is a right triangle, we can use Pythagoras. We have two sides that are known, so we just use Pythagorean theorem and solve for the third. Let's set up the Pythagorean theorem. So you take the sides that are not the hypotenuse are called legs. So we'll take the first leg and we'll square it, just like in Pythagoras theorem. And we'll add the other leg and square that. And this is going to equal the hypotenuse squared, which we know to be 1. So this is 1 squared. Let's do out the square. So 5 squared is 25. So this is going to be 25 over 169 plus y squared equals 1 squared. Well, 1 squared is just 1. So we could write 1, but actually I'm going to prefer to write 169 over 169. And maybe you can see why I want to do it that way. Because when I subtract 25 over 169 from both sides, I want that to be an easy calculation. And that's exactly what I'm going to do right now. I'm going to subtract 25 over 169 on this side and subtract 25 over 169 on that side. And what I'm going to get is I'm going to get y squared equals 144 over 169. And maybe you can see where I'm going with this, because now we square root both top and bottom. Now it's really nice here what they did to us, that the both numerator and denominator in the blue fraction there are going to give me integer square roots. But even if it wasn't an integer square root, that's totally okay. We can handle square roots. So here we get that y equals, I'll just stick with the purple actually, y equals 12 over 13. So yay, this is 12 over 13. Except that we have a slight problem. Does anyone recognize the problem? Is 12 over 13 the answer? It cannot be, because it's not negative. Y is the point, I should say, the coordinate, the red dot there on the bottom, is in the quadrant number 3. And in that quadrant, both cosine and sine must be negative, so this must be negative. So, what am I saying? I'm saying that the sine of theta, which we don't know what that angle is. We could use a calculator at this point, but that's not part of this test, so we don't have to do that, is negative 12 over 13. Okay, so there's one of your two answers, because they asked for two things. They asked for sine and tangent. Okay, if you want me to copy that up here again, you can say, look, sine of theta, there it is. It's negative 12 over 13. Now, what about tangent? Well, good news, we're pretty much done. We have a very simple assignment ahead of us. Remember that tangent equals sine over cosine. So all this really is for us now is the sine, which is minus 12 over 13, divided by the cosine, which we were given as negative 5 over 13. And so this equals, well, I prefer to write it as a fraction. I'm sorry, as just a division problem. So this is going to be minus 12. You know what? Let me give you the color coordination back. This is minus 12 over 13 divided by negative 5, and I'm going to use parentheses because I have a minus. Negative 5 over 13. Okay, and now we do KFC. KFC, of course, means keep, change, flip. And as you know, I'm dyslexic, so it works. Minus 12 over 13. So we keep the first fraction, we change the sign to multiplication, and we flip the other one. So this becomes minus 13 over 5. And then we simplify all that, and the minuses will multiply to give you positive. 13 divided by 13 is 1, so that goes away, and we're left with 12 over 5, otherwise known as 2.4. So this right here is the tangent. This right here is tangent of theta. Okay, that's the tangent of theta. And that is our answer. And that means we're done. But like I said, I have a few things to say, because there's some things we could have done differently, and maybe you would prefer it another way. there's a couple things that come to mind. The first thing that comes to mind is that we could have done the triangle a little bit differently. So what I mean by that is, if you know the cosine is -5 or 13, sometimes I like to, I'll just draw some random triangle, and I'll just put those values, the numerator on one side of the triangle, and the denominator is, of course, the hypotenuse because it's cosine, because it's adjacent over hypotenuse. And then I'll just use Pythagorean theorem on this. I happen to know it's a Pythagorean triple, so I already know it's 12. But even if I didn't know the Pythagorean triple, I would then have a pretty easy calculation. 5 squared plus x squared is 13 squared. And it would just be a little bit more obvious that x squared is 144, and therefore 12. X is 12. And the reason why this might be a little bit better is because once we know that x is 12, it's really easy to take the tangent. It's just opposite over adjacent. So if theta is here, then opposite over adjacent is x over 5, so in this case 12 over 5. And you can see that the other values are still valid. Now, of course, this doesn't have the negatives, so you have to deal with the negatives, and that's in the quadrant. So there's reasons why I don't usually teach it to you guys this way, because the other method just works for everything, and some of you guys don't like to know the other way to do it. So that's fine, but I thought I'd just bring it up. And then the other thing to do is, maybe a way that you could save time, is to really just skip this whole unit circle business, because it's not really totally necessary if you have enough experience with these. You could just start with this right here. You could just say, look, I know cosine squared plus sine squared is hypotenuse squared, or 1 squared, I should say. And so I just set up the equation and then I solve, and that's fine, and you can do that. I just think it's nice to be thorough and clear, and to make sure that you do a good job and do it the right way. Don't skip steps. Don't rush things. Take your time and do it out properly. If you want to get faster, just learn to do it properly and then do it properly faster. And that's just you don't learn to play a piano piece fast the first time. You learn how to play it properly. And once you learn to play it properly and you do it over and over again, then you learn how to play it fast. It's not something you can skip. You have to learn how to do it the right way, correctly, without errors, and then you become fast. You don't get fast by rushing. All right, my friends, that does it for this video. I hope that was helpful to you. Please work on number 11 and try that one. And if you're watching this online on YouTube, you can do that one too. See if you can get the answer. I hope this is helpful to you. Please like, share, and subscribe. Thank you, and see you next time. Buy my merch.